Okay, this is the Vic Academy. We want to look at synthetic division of polynomial equations. This is a good method that we normally use when we want to divide the polynomials instead of using the long division. This one is easy and simpler to understand. Kindly follow the steps and you'll find it interesting. So this is a method for manual performing Euclidean divisions for polynomials. We have one rule called Ruffin's rule, which is a special case of synthetic division. We apply it in algebra. So how do you work out this? So we have an example here. Work out a synthetic division given x cubed minus 12x squared minus 42 divided by x minus 3. So in this case, you can see that our numerator can be written as x cubed, which is our px, minus 12x squared minus 42, and our denominator is x minus 3, and therefore you can get the 0 or the solution to x minus 3, which is our gx, which is our denominator. It's a function of gx. So how are you getting the 0? We are basically saying x minus 3 is equal to 0, and therefore rearranging to find that our 0 is 3. So when x is 3, then this becomes undivided. So that's the point we want. Therefore, that 0, we use it to work in a synthetic division. So the coefficients of px, which is our denominator, we write it as follows. So we are writing it as 1, negative 12, just the way they arranged, 0, negative 42. Okay, then come up the kind of that one. Then our 0, we put our 0 in the left side, on the left side. So we put our 0 of the gx, which is the denominator, at the left hand side. Then next, the first coefficient after the bar is dropped to the last row. So what are we saying? We are saying that here the first, this is the first, this is 1 is the first coefficient, so drop it down, drop it down. So when you drop it down, you'll get this is true, you get this is true. So we have dropped the first coefficient down. Then the dropped number is multiplied by the number before the bar, which is our 0. So we are taking 3, which is our 0, times 1. And what are we getting? 3. Note that this 3 here is our 0 gotten from calculation of the denominator. Then this one here is undropped from here. And then if you multiply these two, you get this one. Then next step, you add. An addition is performed in next column. So what are we doing? We are adding that to this. We add, so that we'll get negative 9. Then what happened next? We apply the same idea now. So this becomes like a special drop, negative 9. So you take 3 again, next step, you multiply by negative 9, you get negative 27. Then after that, what happens? You perform an addition. So you do 0, okay, 0, you add to this negative 27, and therefore you get this. Now remember, there is one step remaining at below negative 42. So what do? You take again 3, okay, you multiply by negative 27, and that gives you what? the answer above here, which is negative 81. And then after that, what do? You sum, addition, add that to this, negative 42 and to negative 81. And what do you get here? You get negative 123. So that final answer is actually the remainder. So it seems that in our equation given here, when you divide the two polynomials, there will be a remainder of negative 123. There will be a remainder of negative 123. So the last term is the remainder, as we have just said, while the rest correspond to the coefficients of the quotient. The terms are written with increasing degree from right to left, beginning with the degree 0. And the remainder, both for the remainder and also for the solution. And therefore, the quotient and the remainder are, so the quotient is given by x squared minus 9x minus 27. And the remainder is negative 123. So these first three here gives us the quotient, and the negative 23 gives us the remainder. That's simply how about synthetic division. If you have question on this, kindly leave a comment. If you have a question that you need an assistant, I will be ready to assist you. Therefore, share with your friends and also subscribe if you have not yet subscribed. So bye, until next time.